All right, Algebra 1, as we continue on our journey of lines, I've decided to skip a lesson on transformations. Don't worry, you'll still get that information. It's just going to come later. I'm going to teach transformations when I do quadratics because it's a little less confusing when we're not dealing with lines. So we're going to move right into 3.6, arithmetic sequence. So you might notice this word, and you might want to be pronouncing this word like I want to, which is arithmetic, right? So if you think about what arithmetic is, you in your elementary years you learn reading, writing, and arithmetic. Arithmetic is just kind of like counting, right? It's like a counting sequence is what we're really looking for today. And so I want to start right there and have you think about something. Whenever you're counting by a number, it doesn't matter what the number is. All right, so if I'm counting by a number, let's just start with like 2's, for instance. If I count by 2's, you have 2, 4, 6, 8, 10, right? Every time we're going up by 2. Makes sense. What about 3's? 3, 6, 9, 12, 15. Okay, so there I'm going up by 3's. What about 5's? We can count by 5's. 5, 10, 15, 20, 25. Okay, so what we see in each of these is what we begin to call a common difference between each of them. Whenever I'm counting by a number, that is considered a common difference. The common difference between each of the ones in the first group here is 2. The second group here would be 3. And the third group there would be 5. Okay, that common difference is very related to this idea that we've already been exploring about the rate of change, which we also call slope. So today, we're just going to be looking at it in a sequence versus in like a slope-intercept form that we've been doing in the past. All right, so here I ask you a question here. It says, do you see a pattern? Okay, so whenever patterns are a big deal in math, so they might have you do this a little bit in your homework where they're having you identify a pattern. Actually, that's what most of this homework is about. So typically what people do when they see numbers go up is they either try to add something or they try to multiply something. Okay, so let's first try to add. Can I add something to 4 to get 9? Yeah, I can add 5. Let's see if the same thing holds up for the next one. 9 plus 5 is 14. 14 plus 5 gives me 19. So the pattern here, hopefully, that you saw was we're going up by 5. All right, so counting by 5s, starting with a 4, though. Okay, so with an arithmetic sequence, this is a group of numbers in which the difference between successive terms is constant. Okay, so each time we go from one number to the next, if that number stays constant, we're dealing with an arithmetic sequence. Okay, so it's a group of numbers that increases at a constant rate. That constant rate has also been called the rate of change. It's also been called the slope of a line. Okay, so here we go. Common differences. The common difference between terms is just the number that it's going up by. If you start with the greater number and subtract going this direction, we can find out what our common difference is. So 5 minus 3 gives me 2. 7 minus 5 gives me 2. 9 minus 7 gives me 2. 11 minus 9 gives me 2. So we're talking about difference. We're going in this direction and we're subtracting. Technically, we could do that in our head the other way and just say, oh, we're going up by 2's, right? But just want you to see that where that word common difference comes from. Difference is also always talking about subtraction. Okay. So, this is important to note that we express that common difference with a variable d, for difference, probably. The d in this case is 2. All right, so example 1a, it says, explain whether or not this sequence is an arithmetic sequence. In order for it to be an arithmetic sequence, it has to have a common difference. So let's just make sure that this has a common difference. All right, so if I go, let's just find the difference between each of these. Okay, so the difference between negative 26 and negative 22 is 4. Negative 18 and negative 22 is 4. Negative 14 and negative 18 is 4. So the common difference here is 4. Okay, so you would say, yes, this is arithmetic. And you could say d is equal to 4. The common difference is equal to 4. All right, that's all they'll want for example A. That's 1a, or I should say example 1. Now we're moving into example 1b, so just another example of this. If we look at the difference between 1 and 4, we get 3. And then between 4 and 9, we get 5. And then between 9 and 25, we get, what is that, 16? So clearly this is not a linear arithmetic sequence, right? Because the slope is changing. So here we would just say no, and we can say there is no common difference. And then we're done with 1b. Okay, so we're just really trying to identify patterns, counting patterns. If we're going up by a constant amount, we're adding by a constant amount, that's going to be an arithmetic sequence. If we're not, it is not. Alright, so the next terms. You can use the common difference in a sequence to determine the next terms. So for instance, if you have this sequence 2, 4, 6, 8, I ask you, could you tell me the next 3 terms in the sequence? Well, most people would just continue to count by 2's, which would be correct, right? So if we're adding 2 each time, we could just add 2 3 more times. So in this case, we would get 10, 12, 14. Okay, so if I give you a D value and they give you a sequence, it's pretty simple to find the next few terms. Example 2 says find the next 4 terms in the sequence. So first of all, what you're going to need to do is find out what the pattern is. Okay, so the easiest way to do this is subtract. If you subtract 9.5 from 11, you're going to see that that comes out to 1.5. Okay, let's make sure it's the same throughout here, and it appears to be. So we're going to go up by 1.5. So if I add 1.5 to 14, I get 15.5. If I add 1.5 to that, I get 17. And then if I add 1.5 to that, I get 18.5. And then add 1.5 to that, I get 20. Okay. So there's some really cool patterns that you can see here. Some people like to point out the fact that every other time we get a whole number, and it's that every other is going up by 3. Right? And that makes sense because 2 times 1.5 is 3. So every second term we should be going up by 3. Some other fun patterns to look at with all of these, but I'm not going to take the time here. So here's an interesting question that I pose to my my Algebra 1 class every year. A lot of people, a lot of times, most years, I have a student or two that can figure out what the 1,000th term would be on this. But for the most part, people are like, huh, how would you do that? And like, I'm not going to sit here and make 1,000 numbers in some pattern and try to find that out. Well, we know that equations in math just relate to rules, right? So here we're following rules. We're just following a standard rule each time that we do this. Okay, so we can build an equation that would work, that would find each, if we can build one that would find each of these in the pattern, an equation with a variable, right, where I'm plugging in the term and then getting this number out. Then what I could do is I can plug in 1,000 for the term and then find out what the 1,000th term is. So I encourage you to try to figure that out. Okay, but I'm going to also help you with this equation. But what I'm hoping that you'll notice is that we can all agree, hopefully, that the common difference would be important in this equation. Okay, so let's see if we can find what that common difference is. So if I take negative 10 and find the difference between that and 3, I believe it's 13. Okay, so each time it's 13 here, and since we're getting further and further and further into the negative, we're actually going down by 13. Alright, so the common difference in this term, the D value, is equal to negative 13. We're going down by 13, right? So that is going to be crucial to our equation when we eventually do our equation. I'm going to come back to this here in just a second. But notice, I think another important thing would be, you know, if we're finding the 1,000th term of something, I think it would also be important to know, first of all, what the difference is between each term. Then, perhaps knowing the first term, knowing where we start would be important, right? So if we take our starting place, what we call this is we call this a sub 1. Okay, this is what you'll start seeing for sequences now. When you're studying a sequence, you'll start to see this notation. A sub 1, so I'm going to take a side note here. A sub 1 means, all this means is first term. Okay, so you can imagine what A sub 1000 means. It just means the 1000th term. And if I said A sub n, that just means the nth term. And what I mean by nth term is it's just an unknown term. So whenever we're dealing with an unknown, we bring in this letter n with a sequence. Okay, so let's explore how to come up with this equation. Now that we know a1 and d, we actually have everything we need for our equation. All right, so let's unpack it. Here we go. So d is, again, the common difference. So let's unpack all of the parts of this equation that we're about to come up with. D in this case would be 2, right? We're going up by 2's. We're starting with 4. First term, again, means A, like you'll see this notation, A1, that means first term. Okay, in this case it is 4. Second term is A2, right, which is just taking A1 and adding D. So I'm showing you a pattern here. Okay, so that's how we got 6. And then the third term is taking A1 and adding 2D. All right, maybe you're starting to see a pattern here. The fourth term is found by taking the first term and adding 3 times D, right? In this case, it's 4 plus 3 times the common difference, which is 2. So we get 4 plus 3 times 2, which is 10. Okay, so now they're asking you what would it be for the nth term if this pattern continues. So notice what's happening with my D's. I'm multiplying D by 1 less than the term that I'm on. Right? Do you see that? Hopefully you're seeing that. You're always multiplying D by 1 less than the term that you're on. Okay, so for the nth term, let's look at that. A sub n would be equal to, in all of these, what's important to note is that we start with our first term. So A1 plus, okay, if we're in the nth term, we don't know which term we're talking about. We're just going to use n. Okay, n minus 1. That's what we did here. We took the term that we were on. This could be considered n, but we just don't know which term we're talking about. Took the term that we were on, we subtracted 1, and then we multiplied that by d. Okay, that's what we're doing with each of these. So in this case, we could say a sub n is equal to 4 plus n minus 1 times d. This would give me, for this particular sequence, this would give me any term that I wanted. And actually I know d, so I'm going to actually plug that in. D here is 2. Okay, so I can simplify this a little bit by using my distributive property, right? And I can say that a sub n is equal to 4 plus 2n minus 2, which is equal to just 2, let me go up here, 2 plus 2n. Okay, so my nth term is equal to 2 plus 2n. So now if I said, what's the 1000th term here? You can plug 1000 in here, and what you end up with is 2002. So the 1000th term in that sequence would be 2002. Now let's come back. In this guy, all right, let's see if you guys can come up with the 1000th term here. All right, so what that would be is a sub n is equal to, and actually we know what the n value is. It's 1000. Okay, we're looking for the 1000th term. It's equal to the first term in the sequence, which would be 3. That's a1. Plus, we have n, which is this guy, 1000, minus 1 times d, negative 13. Okay, so the 1000th term is as simple as simplifying this. So we get 3 plus, this is 999 times negative 13. All right, and if you do that out on your calculators, which let me pull mine out here, probably don't even need to. It's easy enough to do without, but I'll just do it here just for the sake of time. Let's see, plus 3. What I'm getting is negative 12,984. Okay, so that's what your 1000th term would be. We're going to get way into the negative, it looks like there. Okay, so that's how you would find out some ridiculous term. I'm going to have you do that on the test, right? Or I'm going to have to, you're not going to be able to count. You're going to have to use this formula, this equation that we came up with to come up with some ridiculous term like the 1000th term or something like that. Okay, so having this in your notes and knowing what each of those things mean, being able to apply it is going to be very important for this lesson. Okay, so let's keep going here. Oh, and I already did all that, so look at that. All right, so let's go to example 3a. So consider the sequence 3, negative 10, negative 23, negative 36. Write an equation for the nth term of the sequence. All right, I think this is one that we just did, isn't it? So the difference here, the d value is going down by 13. Okay, so this is a negative d value of 13. So it says write an equation for the nth term. Nth term would be this. A sub n is equal to 3, which is a sub 1. So let me just start with this. Remember that this is our nth term equation, which you need to memorize and start getting used to. Okay, so the nth term is equal to, in this case, we know a1. The first term is 3. Okay, so I got that from right here. Plus n minus 1, we don't know n, so we can leave that like that. But we know d, it's negative 13. Okay, I don't really care, I guess, if you leave it in this form. In your textbook, when you check your answers, they may have it simplified where they distribute this out. So that would be 3 minus 13n, be careful with your signs there, plus 13. Okay, if I simplify that a little bit, I get a sub n is equal to 16 minus 13n. Alright, so now I can say, what's the 50th term? You take a 50, you plug it in for n, and you'll know the 50th term. It's an equation. Alright, so 3b. Consider that sequence. Well, let's find the 15th term. So here we go. Let's do it. So if I plug in a 15 for n, that'll tell me the 15th term. Alright, so if I plug in that 15 there, let's do that. So we have 15 times negative 13, which gives me negative 195, and then I'm going to add 16 to that. And I say, okay, the A15, or the 15th term, is equal to negative 179. Alright, so here, I wrote in here, which is okay, but in this case we know what term we're talking about, so we can write A sub 15. Alright, so that's 3b. Let's go to 3c. Just consider the sequence 3, negative 10, negative 23, negative 36, the one that we've been talking about. It says graph the first 5 terms of the sequence. Alright, so they just want us to graph this now. So to graph this, let's take a look at the first term in the sequence is going to be 3. So if I go to, these are terms, the x values are terms in the sequence. So 3 is somewhere, this is going by 10, so 3 is somewhere in here. And then the second term is negative 10, which is there. And then the third term is negative 23, which is there. And the fourth term is negative 36, which is there. So when you're graphing these, you should now relate what you know from the last few lessons, that these things are going to be lines because they have a common difference or a common rate of change or a common slope. All right, and then 3D says which term of the sequence is negative 114. Okay, so for this one, this is a kind of a bit of a jump and a new part of the problem, but it's not too bad. So we're looking for an unknown term. Okay, so that's a sub n. We're just going to use the only equation that we're going to use for these things. Okay, so a sub n is equal to, we know the first term in the sequence, it's 3. Okay, and then we're going to add that to n minus 1 times d. We know our common difference is negative 13. And we know that this whole thing simplifies. The whole thing simplifies to 16 minus 13n. Okay, so what they want to know is which term, if you solved this out, right? If you solved our equation out and you knew an n value to plug in, then you're getting this. So what they want now is they want to say, okay, when is the nth term negative 114? So we're going to substitute it. Okay, then we're going to find what n value, or what term, is n represents the term, is negative 114. Okay, so we're just going to plug it in. All right, so when I do that here, I'm going to subtract 16 from both sides. Okay, so I get negative 130 here is equal to negative 13n. Divide both sides by 13 negative, and n is equal to 10. Okay, so for D, don't let that throw you off. When you know a term and they're asking you which term in the sequence is it, if you know a value for that, just plug it in for a sub n. All right, plug it in for that guy, which is what we did right here, and then solve. All right, so that's 3D. And I guess that's it, guys. So your homework, you have homework sheets for this. We'll do a bunch of these together in class because I know there'll be some questions, but that's okay. We'll catch you guys.